Good morning, sir. This is K. Hardy. I am from second year CSE C section. Today my topic is traveling salesperson problem using branch and bond. Traveling salesperson problem using branch and bond. Introduction to traveling salesperson. The traveling salesperson on problem is a classification optimization problem in a computer science and operations research. It involves finding the shortest possible route that visits a set of cities and returns the origin city. Traveling salesperson has applications in logistics, planning and the manufacturing of microchips, among others. Problem statement. Given a list of cities and the distance between each page, the goal is to determine the shortest possible tour. The solutions must visit each city exactly once before returning the starting city. Traveling salesperson is a NP hard, meaning no polynomial time solution exists for large instance of the problem. Importance of traveling salesperson. Traveling salesperson is not just a theoretical problem. It is a practical implication in a route optimization and resource allocation. It serves as a benchmark for many optimization algorithms and structures. Researchers and practitioners seek efficient methods to approximate solutions for large datasets. Branch and bound overview. Branch and bound is an algorithm design paradigm for solving combinational optimization problem. It is a systematical exploration branch of the solution space to find an optimal solution. This method uses bounds to proven branches that can yield better solution than already found. Branch and bound algorithm. Branching. Original problem is partially into sub-problems. Bounding. Compute the estimated optimal solution of the considered problem and compare to the best no solution. Elimination. Identify node which does not lead to the best solution and eliminate them. Selection. Exploration strategy. Best how branch and bound works. The algorithm starts with an initial feasible solution and the calculations. Bounds on the optimal solution. It divides the problem into smaller subprograms and explores these subproblems recursively. If a subproblem bounded exceeded the current best solution, it is a discard from future consideration. Steps in branch and bound for TSP. Initially with a root node representing the starting city and calculate its lower bound. Generating childs by exploring possible paths from the current city to unvisited cities. Update the lower bound at each step and foreign nodes that exceeded the current best solution. Lower bound calculation. A common method for calculating the lower bound in traveling salesperson problem is to use the minimal spanning tree. The minimum spanning tree represents the minimal cost of connecting all cities without forming any cycles. This bound provides a basic line to evaluate the feasibility and of potential routes. Advantages of brand and bound. It guarantees finding the optimal solution, provide their insufficient computerized time. It pouring process can significantly reduce the searching space, make it efficient for smaller instances. Branch and bound can combine with a static and enhance performance on large datasets. Limitations of branch and bound. This method can be computerized instance and may not be feasible for large instance of traveling person problem. The efficiency of algorithm greatly depends on the quality of bounds used for pawning. In practices, it may require significant memory resources to store the state of the search tree. Conclusion and future directions. The traveling salesperson problem remains a fundamental challenging in optimization. Branch and bound is a powerful technique, but hybrid approaches with heuristics are often preferred in practices. Future research may focus on improving bound and integrating machines learning techniques to enhance efficiency. Thank you.